Hello everyone. So you are welcome to today's class. So today's class is going to be based on approximation, but we are going to look at the subtopic under approximation, which is limit of accuracy. And under this topic, we are going to be looking at the brief explanation of limit of accuracy. Then after that, we look at the types of limits, while the last one will be examples on limit of accuracy. So let me start by explaining what do I mean by limit of accuracy. So limit of accuracy, it simply means the extent to which we can approximate a given measurement. And we do that by approximating to say one decimal place, nearest whole number, one significant figures, two significant figures, and so on like that. So after that, we have types of limit. As we know, if you are given 9 centimeter as a measurement to the length of a stick, so this 9 centimeter is not the actual value. So we have the lower bound of the number, and we have the upper bound of the number. So under types of limit, we have lower limit and upper limit. That depends on what we are converting to, maybe to nearest whole number. So we have the lower limit as the first type of the limit, so lower limit, while the second one is the upper limit. So these are the types of limit. So this will give us, the lower limit will give us the minimum value we can approximate to get 9 centimeter. Depends on what we are correcting to, maybe what we are approximating to, maybe to one decimal place, or to the nearest whole number, or to one significant figure. So the lower limit to approximate to get 9 centimeter, that would be the minimum value or the smallest value. While the second one is the upper limit. So upper limit is what we can approximate to, that is the maximum value we can approximate, or we round it down to give us 9 centimeter. So we can say like 9.49 now. So we can approximate this to 9.5. So from 9 to one decimal place, this will be 9 centimeter. So here is the maximum value. But to the lowest value, we can approximate, the lower limit will be 8.5 centimeter. So how do I arrive at 8.5 centimeter and 9.49 or 9.5 as the case may be? So we are going to do that. I'm going to explain that under the given examples. So I will give you examples on limits of accuracy now. Before I continue, before going to the examples, I would like to explain this note. And the note says, if a measurement is given to the nearest unit, then the maximum possible error is half of that unit. So what do I mean by this? So, I explained types of limit. Assuming the length of this marker is, let's say, 3 centimeter, there's possibility that the 3 centimeter is not the what you measure. So you can measure less than 3 and you can measure above 3. But to measure more than 3, it means there is a little degree of error. To measure below 3, it means there is a little degree of error. And to get that, we are going to, that's why I divide this as lower limit and upper limit. So upper limit will mean you measure above the actual length of the marker. So for the lower limit, you measure below. Then this note now says, if a measurement is given to the nearest unit, let's say to 3 units now, the maximum possible error is half of that unit. So it means whenever, assuming you have minus, let's say instead of 3 units, you measure 2.9. So there is possibility that you have my 0.1 degrees of error. And you can measure 3 let's say 4 or 3.1. So you still have a little degrees of error there. So we have 0.1 degrees of error below and 0.1 degrees of error above. So to get the actual measurement will now be the half of that, which is the note given in in the explanation. So we have the following examples, and the question says, in each of the following, write down the A, limits of accuracy, B, lower and upper bound, that is lower limit and upper limit. Question 1, 78 meters correct to the nearest meter, and 790 kg correct to the nearest 100 kg. So to tackle this type of question, the first thing to do, so let me go to question number 1. So number 1 says 78 meters correct to the nearest meters. So to do this, the first thing to look for is to look for the maximum error. How do we get the maximum error? We are correcting 78 meters to what? Meter. So the meter we are correcting to is the unit. So here we are going to have the maximum error. The maximum error will be half of 1 meters. How do we get the 1 meters? Because we are correcting to meter, and the meter we are correcting to, if you look at this, is unit. It's like we are correcting to the nearest unit. And we have meter here, meter, which is 1. So we have half of 1 meter. And half of 1 meter is equal to what? Is 0.5 meters. So the maximum error will be 0.5 meters. So that is maximum error. So to now get the limit of accuracy, so the limit of accuracy will now be limit of accuracy will now be equal to 78 plus 78 plus or minus 0. So here is either we have the lower and the upper. So we have, okay, this one is 0.5 meters, but here the limit of accuracy will be 78 plus or minus 0.5, then close the bracket, meters. So this is limit of accuracy. That is 78 plus or minus 0.5 meters, because the maximum error we can get when we are converting 78 meters to 1 meter is 0.5 meters. And here, the limit of accuracy, whether below or above, we are going to have 78 plus or minus 0.5 meters. So this is limit of accuracy. Then the second part of the question, this is A part. Then the B part of the question, which is lower band and upper band. So lower band, which is also known as lower limit, lower band will now be equal to 78 meters minus, because we are looking for the number less than 78, so minus 0.5 meters, so which is 77.5 meters. So the lower band, which is the lower limit, is 77.5 meters. Then the second part of the question, which is upper band. Upper band, which is the same thing as upper limit, is 78 meters plus 0.5 meters. So which is equal to 78.5 meters. So this is solution to question number 1, which says 78 meters correct to the nearest meter. Give us this solution. Thank you. Then we move to question 2. And the question 2 says 790 kilogram correct to the nearest 100 kg. So since we are correcting to the nearest 100 kg, the number we are correcting to is 100 kg. Then what will be the half of 100 kg? That is 50 kg. That will be our maximum error. So our maximum error will be equal to half of number we are correcting to, that is 100 kg. Half of 100 kg. And what is half of 100 kg? That is 50 kg. So 50 kg is the maximum error, whether below or above. So if it is, now to get the limit of accuracy, we are going to have limit of accuracy to be equal to 790 plus or minus 50 kg. Let me put this out of the bracket. So 50 close the bracket, then kg. So the limit of accuracy, we have 790 plus or minus 50 kg. That's the limit of accuracy. So the next thing is to get question B, that is the upper band and the lower band. So the lower band will be equal to 790 minus 50 then in kg. So we have 740 kg. So the least value that we can approximate this one to, the least value we can get is 740 kg. Then while the upper band equal to 790 plus 50 then kg. So which is equal to, that is 840 kg. So here is the upper band of the maximum value. We can correct 790 kg to when we are correcting it to what? 100 kg. Thank you. So thank you. This is the end of limits of accuracy. But you need to understand this topic very well, because the understanding of this topic will assist us in dealing with percentage error. So I want you to watch it very well and pay attention on the notes. Then you be expecting a note on or video on percentage error. Thank you.